Figure 11 shows a sketch of the curve with the equation y equals x minus 4 all squared minus 3. Part I. Write down the equation of the line of symmetry of the curve and the coordinates of the minimum point. So it's already been given to me and completed the square form, so I can say straight away that the turning point is 4 minus 3. I got the 4 by just flipping the sign here, and I got the minus 3 from here. So that's the coordinate of the minimum. The line of symmetry will have to pass through that point. The equation of that line is x equals 4. Every point on that line has x coordinate 4. Part II. Find the coordinates of the points of intersection on the curve with the x and the y axis. So I need to know these 3 coordinates. Well, the intersection on the y-axis, that's easy because I know x is 0 there. So if I substituted 0 into my equation here, 0 minus 4 is minus 4. Minus 4 squared is 16. 16 take away 3 is 13. Now, to work out the intersects on the x-axis, I need to make y equals to 0. So I need to solve the equation where x minus 4 all squared minus 3 is equal to 0. So if I add the 3 to both sides and then square root, I find that x minus 4 is equal to either plus root 3 or minus root 3. So therefore the x will be equal to 4 plus root 3 or 4 minus root 3. This is the coordinate 4 plus root 3, and this is the coordinate 4 minus root 3. Part III. The curve is translated by 2, 0. Show that the equation of the translated curve may be written in this form. Right, so if it's translated by this vector, it means it's moving 2 squares to the right. So it's the x coordinates have all had 2 added to them. So that is like the transformation f of x minus 2, because it will be the opposite on the inside of the function there. So that means I can take my original function, let me write down the original function, and instead of having an x here, I'm going to replace that with an x minus 2. Which we can then simplify. So that minus 2 minus 4 is minus 6. We can then expand those brackets and simplify. And that's what we needed to show. So the fact it's been translated by positive 2 in the x direction means we need to have an x minus 2 on the inside of our function. Part 4. Show that the line 8 minus 2x meets the curve at just one point and find the coordinates of that point. So let me just get a bit more space. Because the fact that it's talking about meeting, that's another word for meeting, is intersecting. So therefore I'm thinking simultaneous equations between these 2 lines. So let's take the quadratic, x squared minus 12x plus 33. And when does that meet the line 8 minus 2x? So let's add the 2x to both sides. And let's subtract the 8 from both sides. And on the left-hand side, we can factorise here. And when we factorise, we get a perfect square which has only one solution, as we expected. So x equals 5 is the only solution where that quadratic meets that straight line. We can work out the y coordinate as well by doing 8 minus 2 times 5, which is minus 2. So 5 minus 2 is the only point where these lines touch.